So this one is our part 2 continuation of discussion of question and answer or organic chemistry. If you have not seen the part 1 video, you can follow there. Many conversion, many important type of questions are discussed. So follow the part 1 video, then come to the part 2 video, or else you can follow the part 2 video first, then you can go for part 1 also, because this is only the continuation of question answer. Okay. So from physical properties also basic question may come. Here it is written. Okay, so the question is, why do carboxylic acids possess higher boiling point than corresponding alcohol? If we go for the carboxyl, so here if we go for the first of all the similarity, both can both can form hydrogen bonding. But the thing is, if we go for the acid part particularly, so here we are having this OH, okay, and this can make hydrogen bond with the double bonded O present in the another acid group, and here also another double bonded O present, and here another hydrogen is present, and it can form like this. So actually what is happening here, a dimer has formed through the hydrogen bonding, but in case of alcohol that dimer is not possible. They can form hydrogen bonding with the other molecule, but the dimer is not possible. So in this case the dimer will be more stable. Because of more stability through hydrogen bonding, carboxylic acid will be having higher boiling point than alcohol. And we can compare the carboxylic acids, that boiling point with the alkane with the help of that hydrogen bonding also. Okay. Next, go for the question number 7. Here we are having distinguish between acetic acid and formic acid. So the distinguish test, we can follow various any chemical test which is the correct explanation number will be given. Any chemical test can be used. So if it is correct and justified, number marks will be given. So as in both of the cases, if we go for acetic acid CH3CO OH and formic acid HCO2H, for both of the cases, for this one and for acetaldehyde CH3 C double bonded H acetaldehyde and benzaldehyde, both we can separate by the means of that iodoform test. So here we are having this. In this case we are having alpha hydrogen beside the carbonyl group. Hydrogen is present with the carbon. Here no alpha hydrogen. Here also alpha hydrogen present. Here no alpha hydrogen. So here in the both of the case we can separate them by iodoform test, where iodoform test means I2 we are using, along with we need the base sodium hydroxide, and here which will be giving iodoform test, that will give yellow precipitate of iodoform. So through chemical test, and one thing remember, any distinguish or any what happens when question, you have to explain these in terms of chemical equation. No or word equation will be accepted, only chemical equation will be accepted, and try to balance the equation. Balanced equations are more accepted than unbalanced one. Okay. Then we are having defined aldol reaction and Cannizzaro reaction. First of all, in case of aldol reaction, suppose I am taking here a very easy example. Once you are defining this, that aldol reaction is possible in case of aldehyde, ketones, or wherever in case of keto group is present with the alpha hydrogen. For these cases, aldol reaction or condensation is possible. And when you are describing, not only with the word, you give one example, put on an example in the terms of symbol. So so here we are having alpha hydrogen in both of the cases. For aldol reaction we need, and we need only the basic ingredient sodium hydroxide. Then this carbon will get attached with this carbonyl carbon, and we will get, suppose here we are having C double bonded O CH3, and one of the carbon will get attached with another double bonded O, and that double bonded O will become OH, and here the CH2 will remain here, that hydrogen will remain here that side, and this one is the aldol reaction. And if you want to extend this further, if we heat it, then this hydrogen and this OH group will go out, and here will be the release of water molecule, and double bond will form, and we will get this thing. So this process in presence of basic medium, when ketone or aldehyde, any carbonyl group having alpha hydrogen, get condensed and form with the aldol reaction. And explain this in terms of example also. Okay. Next, go for the Cannizzaro equation, Cannizzaro reaction. For Cannizzaro reaction, it will be little different. No alpha hydrogen. The first condition is no alpha hydrogen should be present. Suppose we are taking two formaldehyde here. Two formaldehyde here. Formaldehyde, they are the aldehydes with no alpha hydrogen. So no alpha hydrogen, and we are adding sodium hydroxide in the medium. In presence of sodium hydroxide, these two will get reacted with sodium hydroxide. One will get oxidized, will form CH2. One will get reduced, will form CH2H. Another will get oxidized, will form formic acid. So this one is the Cannizzaro reaction. In presence of base without any alpha hydrogen, presence of alpha hydrogen, one will get oxidized, another will get reduced, and they will get methanol and formic acid. In this case, this will be the Cannizzaro reaction. Okay? So another reaction was Wolff-Kishner reduction. So oxidation reduction also the part of the syllabus. So if we go for the Wolff-Kishner reduction, in case of Wolff-Kishner reduction, we are writing this Wolff-Kishner. Our reagent is here hydrogen. Hydrogen will be there. So our reagent is hydrogen with the presence of base KOH, and our conversion will be from any carbonyl group. From any carbonyl group to it, through its reduction, hydrogen will get added, and in presence of double bonded O, two hydrogen will get added and it will be reduced to that. This one is Wolff-Kishner reduction. This one is our Wolff-Kishner reduction. Question number 9 is given as give equation for the following. For coupling reaction, we need first of all a source of electron donor. That can be, suppose we can take as our example as our syllabus, we can take that as beta naphthol. So this one is the beta naphthol, and we should have for coupling reaction the diazonium salt. We must have the diazonium salt, and through that they will get coupled and it will form this type of thing. This type of thing we will get here. OH will be there at that position, the first position here. Then will come like this. This will have a beautiful orange or red colored dye. So this is named as the coupling reaction. Okay. Next we are having benzoylation. Benzoylation, this one is also from nitrogen compound, nitrogenous compound. So if we go for benzoylation reaction, suppose we are taking here COCl. This one is the benzyl chloride. And the benzoylation reaction, we need another electron donor that will act as the nucleophile. So we are taking here just the simple methylamine. So this is the electron rich compound. This will be the nucleophile, and through benzoylation it will form NH through the nitrogen. That ketone will get attached. So this reaction is called benzoylation. For benzoylation we need the benzyl chloride. Okay. Next we have to give the equation for Sandmeyer's reaction. So Sandmeyer's reaction, once we got the diazonium salt, from diazonium salt we can go to various sites from any chlorobenzene, iodobenzene, bromobenzene, and we can achieve through that Sandmeyer reaction. So first we are having diazonium salt as the initial reactant. Then we are adding, suppose CuCl, HCl for Sandmeyer reaction, and we will get here that chlorine chlorobenzene we have got. Next, complete the following reaction. Here we are having complete the following reaction. Acetamide is reacting with bromine. Acetamide having CH3CO NH2 formula. Along with bromine bromine is there, potassium hydroxide is there, and both of them are the reagent of Hofmann degradation. Hofmann degradation means one carbon less will be there, and this is a process of formation of amine from amide. So this is our acetamide, and bromine KOH, it will give you methylamine CH3NH2. Okay, so we have discussed here this much. Few questions, maybe the question is few, but various type of questions are discussed from the organic chemistry, and you can consider this as the probable questions also. And you can physical properties, or for the conversion, the word equation, the IPSC name, common name, for common name you can consider also. So if this video will be helpful for your exam, let me know after the exam in the comment box. And if this video is helpful, you think, for now, give a like, and share with your friends also if they are also preparing for ISC. And thank you for watching.